Hello everyone, welcome back to Joe Microsphere, your number one place for GIS and Remote Sensing tutorial. So in this video, I'm going to show you how you can calculate for NDWI, that is the Normalized Difference Water Index, using Landsat Collection to Level 2 Surface Reflectance data. If you are working on water mapping, drought monitoring, wetland studies, hydrology, or flood analysis, this is the perfect tutorial for you. So NDWI stands for the Normalized Difference Water Index, as I already said, and it's used to detect open water features such as river, lake, wetland, reservoir, flooded area. It works by comparing the reflectance of green band and then the near infrared band. That is, when you are dealing with Landsat Collection 2 Level 2 Landsat 8, we are going to use band 3 and then the band 5. So the NDWI become very useful for identifying water bodies, which I have already said, and then the formula too. So let's look at the process that we are going to go through, and then why we choose Collection 2 Level 2 image. Okay, so why we choose the level 2 surface reflectance is Landsat level 2 data are already atmosphere corrected, meaning the effect of haze, aerosols, and the water vapor has been removed, which when you are using level 1, you need to do all these corrections before you can use the image, and then this give an accurate water detection, a sharper boundary between the land and the water, better NDWI values, sorry, and then we have especially the hazy and the cloud environment. So when you are mapping around hazy or cloud environment, level 2 reflectance surface image is recommended. And then we have, now we can go through the simple steps for calculating for our NDWI, which you download your Landsat image from ArcGIS or Google Earth Engine, and then you extract it, and then you import your band 3 and then your band 5. So band 3 is the green and band 5 is a near infrared, which then after you import it, this is the formula, which is going to be band 3 minus band 5 and then band 3 plus band 5, which is very simple. And then so after calculating for your NDWI, you are going to import your study area or your shapefile, and then you click to your study area, then you apply the threshold. So a threshold of greater than 1 is likely a water area, and then threshold less than 0 is land, vegetation, soil, or built up area. Okay, so now let's quickly get into the practical aspect. Alright, so first of all, you launch your ArcGIS, and then you open your projects like this, and then we have two ways of connecting data. You can either you go to map and then you use add data, or you go to your view and then you click on your catalog, and then you right click on folder here, and then you go to add connection here. So on the add connection folder, you are going to locate to where you have saved your image, that's the level 2 image. And then if you look here, you can see I have level 1 image here and then level 2 image here. So this one, since we are dealing with level 2 image, I'm going to import one of the level 2 image here, which you can see it here. So I'm going to import this one and then open my folder. Alright, so this is my level 2 image. As you can see, we have level 2 SP, and then you click on the drop down arrow here. So now you can see I have all the bands here, and then I'm not going to use all these bands. I just need band 3 and then band 5, so I'll just add my band 3 and then also add my band 5. Alright, so it's still reading, so let me wait a small. Alright, so this is my band 3. Alright, so this is my band 3, which I'm going to load my band 5 to. Alright, so now I have my band 3 and my band 5 here. So now I can close my catalog and then rename my bands. So I'm just giving it band 3 and then band 5. Alright, so now I have all my image here, which is still loading. So after getting all your image, and then the next thing you need to do is you need to open your raster calculator to calculate for your NDWI. So you go to your view and then you choose your geoprocessing tool here. Alright, so on your geoprocessing tool, you are going to search for your raster calculator. So you search for your raster calculator. Alright, so you search for your raster calculator. That is the spatial analysis tool. Then you click on it. Okay, so this is my raster calculator. You can see I have my band 3 and my band 5 here, and then when you go back and then you look into the formula says band 3 minus band 5 or in brackets divided by band 3 plus band 5 or in brackets. So that's the same thing that we are going to do for in our raster calculator. So first of all, you bring your brackets, which you can type it on your keyboard. Then we have your band 3. Alright, so let me go back to the formula for us to verify. Alright, so we have brackets. You open brackets, you type band 3 plus band minus band 5, then you close the bracket divided by band 3 plus band 5. So alright, so you double click on your band 3, then you can see it here. Then you click on your minus here, then you double click on band 5, then after then you close the brackets and then you divide it by then you open another bracket again, then you type your band 3. Alright, you type your band 3 plus your band 5 here. Alright, so now you can see I have band 3 minus band 5 or in bracket divided by band 3 plus band 5 or in bracket. So here I'm going to rename it, and then here if you don't want the location you can just change it. So I'm going to rename it to NDWI, that's the Normalized Difference Water Index. And then now you can see we are good to go to run. So let's run and then see the result that we are going to get. Alright, so now we have our NDWI here, which we are going to zoom to layer to view the image. Alright, so now we have the image. This is the whole image that we did the NDWI for, but we don't want the whole image. We just want to clip to our study area. So here we don't need all these band 3 and band 5, which we are not going to use. So now you can see we have a value of 0.099. Then when you look at the threshold, you can see a threshold of greater than 0 is likely water, and then less than 0 is land and vegetation, soil and the built-up. So when you look here, you can see all the places that fall within the 0.09 is a water or wetland area, and then area on the negative 0.5 is the built-up, and then the other soil, and then the other classes. So now let's go and then bring our shapefile. So you go and then you locate to where you have your shapefile. So let me check. Okay, so which shapefile should I use? let me try this one and see if it will cover the steady area. Alright, so it's way away from the steady area, so let me import another shape file. Alright, so let me use this one here. Alright, so now you can see where our steady area is. So what we are going to do next is we are going to clip to our steady area. So we are going to clip our NDWI to our steady area to get only NDWI for that steady area. So you can search clip on the geoprocessing tool, then you will see clip raster data management tool. You choose that one. So your input feature is going to be your NDWI, and then your output extent is going to be your steady area. Then you check on use input feature as clipping geometry, and then you click on run. Okay, so now we can uncheck the first NDWI, which we are going to make our steady area hollow so that we can see. Alright, so we are going to make it hollow. Okay, and then now we can zoom our NDWI clip to layer so that we can see it work. Okay, so this is our final NDWI, and then the threshold said a value that is greater than 0 is a wetland or a water body. So when you look at this steady area, you can see where we have the whitish area, that is the 0.02 is the water body. So here is a lake, and then where we have the negative 0.30 is a vegetation, and then the built up, and then the other colors, and then we have some other water body, and then some built up here. So this is a simple way that you can calculate for your NDWI. And then the last thing is you can change the color. Here you click on the color ramp, and then you go to your color scheme here. Alright, so now you can change the color to any color of your choice. So now you can see where the water body is. So here's where we have the lake, and then the other classes. So this is a simple way that you can use to calculate for NDWI. So I hope this video was helpful, and please don't forget to subscribe, share, like, and then comment. And then if you have any concern, you can leave it on the comment section. Thank you very much for your attention.